thanks to come to this talk about reactive programming. Well, first of all, I must say that I don't feel like a super hacker. It's like I'm just cold. Okay, that's why I wear this hood. And well, I'm Ricardo Sanz. I'm a Drupal developer since I think 8 or 9 years ago, and on DevOps as well. You can find me on Drupal.org. My username is Tunic, and Twitter Sanzante. And I'm one of the founders of Metadrop, a company from Spain, where we are very happy to solve complex problems using Drupal and related technologies. So we are here to talk about reactive programming. Let's say that it's a way to manage asynchronicity. I'm sorry if someone thought it was a talk about React. It's not about React, but the reactive programming can be used with React or Vue or Angular. Well, in Angular does have the ReactiveX library. This talk is based on this library. There are other libraries that implement reactive programming, but I think this is the one that has more momentum. And this library is usable in many languages in addition to JavaScript, in PHP, Java, Scala, C#, C++, Python, and other languages. Okay, but what does reactive programming really offer? Well, the advantages of the reactive programming is that it greatly simplifies asynchronous working. It's very easy to combine and manage asynchronous data sources. For example, combining data from different external APIs, events from the user, or any other complex interactions. And it generates a shorter, simpler, and more intuitive code. What it leads to a better maintainability. About that little asterisk, I must say that it's true that it's what I say, but you have to deprogram yourself a little bit from the structured object-oriented programming paradigm, because sometimes it feels a little bit strange when you don't know about reactive programming. Okay, and what we do mean by asynchronicity? That's the events that happen over time that we can't predict. This is very common in the browser because it's an asynchronous environment. If we examine a Drupal request, we find that the execution path it's more or less predictable. It's complex, but it's predictable. And data is available when needed. When a database query is done, we assume that result, success or failure, it's available in the next line of code. It's the same for reading a file or other operations. But in browser, this is not true. We don't know when many operation will return their data. AJAX operations are the main example, but it's the same for workers, user interaction, WebSockets, timers, animation, and other sources of asynchronicity. And this makes very complex to manage all these things. So how we can manage this uncertainty, this asynchronicity? The first solution, it's callbacks. It's something that I suppose you know. It's the simple reaction to an event. It's the simple and classic approach. It's just a function call. When an event is received, a function is called. This function processes the event and its data. It's pretty simple. Because of their simplicity, they don't allow many possibilities. It's only recommended for simple reaction upon events, because coding complex reactions is hard. And things start to go complicated when within a callback you need more actions to process the response that requires more callbacks. So this usually leads to something called the callback hell. That it's something like this. It's typical from callbacks. It's nested code because of successive callbacks. This code is not easy to read. It's not clean and it's not elegant, as you see. So the next approach is to use promises. The promises more or less are objects that wrap asynchronous operations and react when there is a result. They are almost callbacks turned into objects. They greatly improve flow and error management. They allow to define reactions on success and reaction on error, and they are also allow to chain action for response. The promises are a big improvement, but they have certain limitations. I forgot to add that they were added to the ES 2015, so they are part of the JavaScript language. The limitation of the promises are, for example, that they are resolved only once. They return a single value. So if you want to repeat an action, you must run the code that makes the action and processes the response of the promise again. Usually you can do it calling again the function that manages this, so it's not a big deal. But you will need to control this re-execution process. This works well for managing set timeouts or simple HTTP request responses, but falls short when dealing with set interval or WebSockets, for example. Once the promise has been fulfilled, it no longer returns values. Following the execution flow may not be trivial. There is, for example, a post from the developer of PouchDB explaining the different ways of using promises, and with slightly different code, you have different result. So it's when you know it very well, well, you know why it does, but you have to know it very well. They are not lazy. Well, as the promise is created, the code that tries to solve it's executed immediately. So it's assumed that the answer is needed now. And they are not cancelable. Except using some libraries like Bluebird, I think. Once the promise is created, it will try to resolve or fall, but you can't cancel the promise. Although you can, of course, ignore the result. This can result in wasted resources. And of course, you have the promise hell, that it's similar to the callback hell. Usually it's because you are using it in the wrong way, but with complex interactions, you may have something similar to the promise, to the callback hell. So we go to the next solution, that is the reactive programming. We can say that it brings functional programming capabilities to imperative programming. It's programming using asynchronous data streams and by declaring data pipes that process and transform the data that crosses them. Before explaining why reactive programming is a great way of dealing with asynchronicity, let's see the basics of the reactive programming. We need it to believe what I'm claiming. So let's see the necessary concepts about the reactive programming. Sorry, I forgot to say that that it's at the end reactive programming needs declaration of reactions to change. That's the main thing about reactive programming. Okay. Well, the first concept is the plumbing. It's about creating data pipes. Okay. In reactive programming, you create pipes for the data, and as said before, data pipes that process and transform the data that crosses them. You create that plumbing system to fulfill your application needs. It's a plumbing system to move our asynchronous data around, transform it, and affect our application components. Okay, so let's see this plumbing system, and with the most simple element that will be a simple pipe. Okay. The simple pipe is just like an event listener, for example. It's just a data source and then an action, a reaction on that action. Okay. For example, an event is generated in the browser, which is captured, and then an appropriate action is taken. In this case, showing an element of the DOM. There, you see that there is a flow of data that goes from the source of the event to its reception in the listener. This is nothing mysterious, it's what we do every day, okay? But it's the most simple pipe. And what would be a complex pipe? A complex pipe it's the same, but we add transformation in the middle, okay? Those are the interesting ones. One example could be the transformation from a click to a instantiated object list. Okay. For example, at some point the user clicks a button. This click becomes a URL that serves, for example, a competition's classification data. Let's say, but it's just the URL. Then that URL becomes the data contained in the URL because we fetched it. And then we get the content of that URL and instantiate the objects with the data of that URL. So the thing is that the initial data, just a click from the user, has traveled the pipe and has been transformed in different things until the final action, that is the assignment to a variable. This is nothing new, it's what we do in every day. But using callbacks or promise will be not so straightforward. With reactive programming, you can define that pipe and see in a more easy way how it's your application wire up. So the thing is to create pipes for the data, and how we create those pipes, how do you declare those reactions to change. Well, first main piece are the observables. Let's say that they are just things that can be observed, boxes where the data comes from. Basically, they are the observer part of the observer pattern. We could say that there are data streams. It's more complex than that, but I don't want to get into thick definitions. So let's say they are just data streams. They change over time, or they emit values over time, so they are difficult to visualize. Because of this, we have the marble diagrams. That is a way to explain what an observable does over time, and they are important to understand how they behave. Well, I forgot to say that they emit data until they finish or an error is triggered. Not like, for example, the promises that they result once. The observables, they're just emitters of data, okay? Until they finalize or they have an error. Well, the marble diagrams, as I say, it's hard to understand what observable does over time. So this diagram are designed to show, to explain easily, to see easily what they do. Those are those examples of Marvel diagrams. They are read from left to right, okay? Representing time, obviously. It's a value emitted by the observable. And the vertical line of the first example, it indicates that the flow has ended. The observable has finished. And the cross indicates that it has emitted an error. In both cases, the flow is closed. The first flow is just observable data flow that emits four values. One first value, A1, then wait a little bit, then two values, then it waits a little bit more, and then the fourth value. The same for the other example, that it's with three values and then an error occurs. It's those diagrams, as I say, helps to understand what they do, and especially when you use the reactive programming and when you use the second important piece, that it's the operators. The operators are the items that allow to change streams. They allow to transform the data in a more or less complex ways, but they also allow flows to be modulated, for example, preventing data from passing if it does not meet certain properties. They also serve to create observables, for example, to create an observable from an event of the DOM, so that when the event occurs, the observable emits the event. So we can create events from any event we know of the DOM or wherever we have in the browser. Let's see a couple of examples of the operators. And they can combine streams. This is, for example, one operator, a filter one. It's very simple. It just filters values that are not even. So you see we have the first observable that emits several values. Then we chain it with the filter operator, and the filter only emits those values that match the condition. Okay, this is a way of creating our data pipes. One of the for example, if we want to filter some values, we should use this operator. We have many other operators, but obviously I'm not going to explain them here. But for example, we have also the map operator that transforms values. In this case, just multiplying by 10. Obviously, those are simple operators. It's just to explain the idea of the operators. So we have observables or data streams, and we have operators that manage those data streams. So let's see a few examples of code. It's I hope you understand them. For me, they are easy, but maybe it's because I'm used to. But I think that it could be explained in more detail why the reactive programming is so useful. So let's create a chronometer using streams. This example is a bit absurd. It doesn't show the power of the streams, but it does show how they work. Okay. So we have a manual chronometer that accumulates time, a button to enable it to start accumulating, and a button to pause or continue the chronometer. There is a working example here, just to see how it is. Oops, a little bit complex to here. So when the page is loaded, we have this clock that it's adding seconds. Then we have a button to start our manual clock, and we have the pause and unpause button. It's very simple. We click start, and it starts counting. You can pause it. Okay. And then start again. Okay, it's very simple. This is very simple to do with promises or callbacks, but it's good to explain the observables and operators. So, what's the plumbing system we will have to implement this? Something like this. Okay, we have the pause button that emits values when you pause it, and then what it does is just the reaction to that change is just to toggle the pause bar, an internal pause bar. Then we have the tick. It's a single, it's like set interval, emitting a value each second that it reacts to this change, updating the clock that starts counting when we load the page. And we have another source of synchronicity that it's the start button that the user clicks. So, and here what we have here, it's a combined operator or wait for all that has two input streams and emits one value when it has when all its sources have emitted a value. So what is this doing at the end? It's just stopping the flow until the user pushes the start button. Okay. So because the ticks, they are going through this pipe and going to combine, but until the user needs to click start button to let the flow continue. And then we have another operator that it's the filter that using the pause bar that we change with the pause button stops or lets the flow continue. At the end, when a value reaches the action, just the chronometer updates and adds a new second. So with this kind of plumbing system, we have implemented that functionality. The code, it will be something like this. That I'm going to be, well, I think it's, well, let's see. We have a clock value with 0. This is the initial value. We have the clock on, that it's counting or not adding time to our chronometer, and then we have an observable from the start button. That's one of our observable created from the click event.
Quick question: is the $sign just a convention?
Yeah, it's a convention. It's a way to declare to say that it's a string variable. Then we have another observable from the pause button. So we have two streams now, and then we have the third stream that it's the tick, the clock tick, emitting a value each second. Then what do? We declare one reaction that it's when pause button is clicked, toggle the clock on variable. Simple. We have another reaction that it's when the click ticks, just update the main clock, the one that it's always adding time when we load the page. And then the functionality, the complex functionality, it's combining two streams. First is the clock tick, and the second is the start button. As you see, we call that operator. And then we add the next operator, that it's the filter, with the condition that is checking the clock on variable, and at the end we just subscribe to that pipe and add the reaction that it's to add a new value. Okay, so if we look back, we have more or less this plumbing system that you can write with this code, that as you see, it's more or less intuitive. Okay. Another example. I don't know if you remember this game. It's quite old. It's a button killer. You have to click button as fast as you can, so your athlete moves faster. And so we are going to create the button killerism, if I may say, functionality that detects the clicks in a row, double, triplet, etc. Time is counted from the first click. When you click, a time window is open and counts all the clicks that enter in that time window. We can see how it works, because I think it's better. Okay. As you see, if I click, I have detected 4 clicks. So 2. If I try to go faster, I can get 4, 5, 3. Okay. If you try to do it with promises or callbacks, probably you will have not super complex code, but complex code with managing the internal state and some time counters to control the time window. Using reactive programming, I think it's again very intuitive. Okay, how we do it? Well, we have the button. We have observable with the clicks of the button. We have a text to put the result of our clicks. And then we create a multi-click stream. This is a stream, observable, emitting the double, triplet clicks that had been detected. How we do? We get the click stream. We have an operator that it's the buffer operator. That what it does is to group values emitted by the other stream. This is the time window. Okay, when a value is emitted, the buffer starts the open window that is closed when the other observable, the one that it's an interval of 2/3 seconds, emits a value. So when the first click arrives, the window is open, the time window is open. It reads all the clicks that entered in that time window, and then emits the values captured. In this case, it's a list. So what we do is we only want to count how many clicks, so we just take the length, and then another filter to filter out those clicks that are not double or triple or whatever. As you see, it's just to add operators. And then we have that stream, that multi-click stream, and we are going to do two things. One is subscribe to that operator and add the clicks that we have detected, double, triple, etc. And we subscribe to it again with a delay of 3 seconds. And when after those 3 seconds, we remove one of the elements of the list of clicks. So this is why when I click here, 3 seconds later, one element disappears and then the other. Okay. So this behavior that I think with other kind of programming could be not easy, we can solve with this piece of code that I think it's short, intuitive, and kind of simple. Another example, it's one I said before in the previous slides, that it's requesting a URL and instantiate objects. Okay, so we have a mouse click and that compares to a URL, then a URL content, then instantiate objects, and then assign them to a variable. Well, we have the observable from the click button, then we map that click to an URL, then we fetch that URL it's important to note that http.get function it's an asynchronous operation. That's why we are using flat map, but the reactive library handles that. Then we map the items from the JSON items to classes, to instance of one class. And then we subscribe and assign that list to an internal variable with those 4 lines of code. Okay, but it is simple. What if we want to, for example, add auto-refresh functionality? Well, in that case, we do the same. First, we have the click observable. Then we merge it with another observable that ticks each 60 seconds. So that merge operator emits a value whenever 60 seconds have passed or the user clicks a button. And then we do the same as before. Map to a URL, fetch the data, instantiate, and assign to a local variable. And if we want to have the auto refresh to be deactivable, well, then we start with the observable that emits value each 60 seconds. Then we have an operator to filter that values when the auto refresh is off. So while it's off, no other values are emitted here from the filter. And then we merge again with the click observable. So at this point we have values that are emitted when the user clicks or when 60 seconds have passed and the auto refresh is on. And then the same: map, fetch, instantiate, and subscribe, and assign the value. And what about the error management? Well, the error management, it's simple. We have the same example as before. And when any of the observables triggers an error, that error it traverses the pipe until it finds a catch operator. And this operator, what it does is just to catch those errors and inject a new operator. In this case, what I have done is just to emit the same list of items we already have. So when we subscribe to, when we process the subscription of the event, the instance are not modified. We get the same list. Okay, we could use another thing. We could, I don't know, maybe returning an empty list, but in that case we will lose the data we already have. So I think it's better to do this. But as you see, it's very easy to to modify the pipe and add different operators to modify data and program different behaviors. Of course, those examples are not especially complex, but I think that you can get the idea. With the reactive programming, you can create very complex behaviors, and in a code that it's very dense, short, but at the same time it's intuitive. So why reactive programming? Because you can express from simple reactions to extremely complex reactions to change. Callbacks, for example, they only express simple reactions as well as promises. No more else. Reactive programming is not about nesting code, so you are not going to have code heads like promises or callbacks. The observables resolve as many times as needed, not like promises or callbacks. They just emit values, not just one. They emit any, not just one, but any values. Execution flow is intuitive. You have to read the pipe. For complex pipe, it's not so obvious, but I bet that it would be worse with promises. And of course, you have to be used to operators to understand the flow, but it's not hard. It's not hard. It's lazy, but I have to add that could be not lazy if you need it, because it's very flexible and it's cancelable. The observables are cancelable, so you can save your resources. So when to use the reactive programming? With many asynchronous data sources, that it's something that it's going to happen as front ends are going more and more complex. Because with reactive programming, it's easier to manage many data sources. With complex interactions, because it's easy to program complex interactions with reactive programming plumbing, as I have shown, or complex interdependency, because same as before, plumbing makes those things easy. Or for example, to avoid internal state that manage asynchronous events. That's remember the example from the button killer. Doing that with promises or callbacks, you will need to manage the internal state with some time counters and other things. And reactive programming does it for you, so it's more simple. You have less things to manage in your head. Now I want to share a personal example. This is the WorkActually mobile app. It's one of our clients. You see 3 drop downs. Each one is dependent on the previous. If you change the next drop down, change. The data is not just retrieved from an endpoint. We need some previous data to render drop downs, identifiers, labels, etc. So we have dependent data. You could argue that API should be simpler to use, but I agree, but it wasn't the case, so we had to stick to already existent API. Data is refreshed sometimes very often. While this view is pretty static, the underlying library that accesses the API is prepared to refresh data automatically and on demand. And obviously this will affect the display of data, which you have to control that refreshing. An API should work offline. So library builds a local data repository with the fetched data, requesting fresh data when it's outdated. The result is a pretty asynchronous hell. Very hard to manage. We worked on this with AngularJS without reactive programming. We lost some of our mental health those days because of the complexity. Then we did it again using Angular with reactive programming. And although it was hard because we had to learn how to use it, the asynchronous hell just became a complex but funny problem to solve. So that's for us was a big difference between using reactive programming or not using it. In this case, the problem was managing data sources and also the graphical interface. I can't show you the code because it's a little bit complex. But if we have time, we can show you another example from a good tutorial that you should read if you are interested in get more information about reactive programming. About the observables and the reactive programming, I have to say that they are not just event emitter; they are more complex than that, because they can be asynchronous or synchronous. They can be cold or hot. This is a concept related to how they respond when someone subscribes to them. Can be multicast or unicast. and can share or not the data sources with their subscriptors. This probably doesn't ring a bell on you, but it's related on how the data is created when someone subscribes to the observable. The thing is that it's very flexible. You can do it. It's not that you can do it, but the observable have different behaviors that are very useful to adapt to your application needs. So, well, why to adopt? First of all, because the others have already done it. All those companies use it internally, well, on their products. Angular, for example, use it extensively. And, well, because it expresses very complex models. It handles any data source. You can put any data source in an observable. They have been proposed for JavaScript standard, currently in stage 1. They are still in the stage 1, but it seems to be, they are okay. Probably will go to the next stage eventually. And well, let's code, improve maintainability. I think that it's the most important reason. And it's available in many languages. So if you learn to use it in JavaScript, you could use it in other languages. And well, asynchronicity. If you deal with asynchronicity, you probably may benefit using reactive programming. I want to add some links at the end of this presentation. The first is this introduction to reactive programming you have been missing. It's a great tutorial or introduction about reactive programming. It's dense. You are not going to understand the first time you read, probably, but you have all the keys you need on that introduction. It's something that it's worth to read. The interactive marble diagrams. This is a web where you can see the different operators working interactively. It's very handy to understand the purpose of the different operators. Well, the RX visualizer. It's a web to visualize some codes using observables working live. It's also very useful to understand how reactive programming works. Of course, the ReactiveX website and the blog of Ben Les, that it's one of the core team of the ReactiveX library. And well, I think that's all. I hope didn't went too fast. Questions? Yeah?
For that archery example, was that a mobile application?
There is a mobile application, yeah.
So, what kind of, was it a native application? Was it React Native? How are you?
No, it's with Ionic and Angular.
With Ionic, okay.
Mm-hmm. Yeah, but as I said, you can use the reactive programming in React if you want, or Vue, or whatever you use. It's just to add a library to your JavaScript source.
So that would work within React Native, to your knowledge?
I don't know, because sorry, I didn't check. But as long as React Native users can use JavaScript, it will be. If not, no. Yeah.
Yeah. Today, almost anything uses promises.
Yeah, I know.
So, yeah.
I know.
So
yeah, but I mean.
What's your approach to migrating an application which uses all promises?
Well, the good thing is that as I said, you can introduce into an observable any kind of data or data source. For example, you can create observables from a promise. So if you are using a library that uses promises, for example, in my case, we are using PouchDB that uses promises. We only have to wrap the promise into in an observable and use it normally.
So you're wrapping every promise that you have to an observable, or you're just like saying like, oh, this is a promise. Okay, it's not like so complex that I have to use the observable approach.
The thing is that when you use the API from PouchDB in this case, or any other library with promises, usually the API returns promises. So instead of switching and use promises in your code, just wrap the resulting promises into an observable and then use it normally. I don't know if that answered your question.
Yeah, it helps.
It helps. Okay. Yes?
Okay, so after reading the introduction to reactive programming, I was like absolutely fascinated. It's great in theory, but I still haven't seen any like production code. Can you show us like just a little bit, or how it works like in practice, or?
The project. I mean, I have that project I could open, but means it's big, and I'm not sure if it's good to show it here and to be recorded. But if you want, I can show you to you or to any people interested. But now it's working. All the develops we are doing now, it's using reactive programming. But also you have to take into account that any Angular code, I don't know exactly which version, about 4, about 3, I don't remember. They use reactive programming internally. I mean the ReactiveX library, it's totally. Coupled with not coupled, but Angular uses it extensively internally, and well, if you want to use it, you can use it. You can use Angular without the observables, but you're going to face the problems you have with promises or callbacks. So probably any Angular code should use reactive programming. Maybe it's not so obvious that it's using it, but internally, yes, it is using. Did you try to do production code with reactive programming?
No, I haven't. And I'm not using Angular. I started the project with Angular 1.
And, do you mean Angular JS? Do you mean Angular JS? Not Angular 1, but Angular JS. I mean, because Angular, there is the Angular 1 or Angular JS. It's more related to React or Vue than Angular. That it's Angular is Angular 2 and above. That is totally different. Between other reasons, because it uses TypeScript instead of JavaScript. That it's a language that can be, well, that it's transpiled to JavaScript. You can use Angular with JavaScript, but well, this is another talk that I'm not so interested in, but it's another topic.
Okay,
I think he was first. Sorry. Yeah.
Have you had like run into a situation where you've needed to integrate it with a more traditional, like just maybe async await style library?
No, I have only used promises, but at the end, await and async, it's like promises, not 2.0, but it's like a step further.
Yeah.
Probably, for sure, you can introduce those async await, well, especially await, I suppose, into an observable stream. Yeah.
What are your thoughts on using generators?
Sorry?
What are your thoughts on using generators?
Yeah, that's a good question because in some way with generators, you can have something that resembles the observables. At the end, it's just a function that when you call it, you have a new value. But the reactive programming is not only about an observable that emits values, but also about all the operators that manage those observables, that create that plumbing system. And also, I didn't dig too much into it, but that library, it has many other not data types, but data objects with more functionality. So generators, probably in certain situations, it's better to just use a generator instead of adding the whole reactive programming library. But I think that they are not, and they are not the same, or they don't overlap totally with the reactive programming. Any other question? Okay, so thanks for coming.